Hello, everybody. My name is Alex Toddling, and I'm the second participant in the Neuralink study, and I'm here to count us down to the demo in 5, 4, 3, 2, 1. Welcome to the deep dive. That was Alex Toddling, participant 2, really setting the stage for what we're looking at today.
Yeah, quite the intro.
Right. So our mission today is, well, to unpack the latest from Neuralink. This company is, right at the edge trying to enhance human capabilities.
And it's a huge vision, isn't it? Solving brain issues, tackling injuries.
Exactly. A really ambitious future they're painting for humanity.
And it all kind of stems from this core idea they talk about. You are your brain. The idea that, everything we are, everything we experience, it's happening there. Trillions of neurons, synapses firing away.
It gets pretty fundamental, pretty fast.
It really does. And with this direct access Neuralink provides, we're not just talking philosophy anymore. We might actually get like an empirical window into how thought works, maybe even consciousness itself.
That's mind-bending stuff.
Right.
But let's also ground this a bit because, the sci-fi ideas can run wild.
True.
It's really important to understand that Neuralink is being incredibly cautious here. Very slow, very deliberate.
Yeah, they emphasize that. Exhaustive regulatory approvals, working super closely with government oversight.
And the safety record, so far anyway, seems really strong with the human implants. They're saying every single one is working and working well.
Which is crucial, obviously. You can't rush this kind of thing.
Absolutely not. So for you listening, what we want to do today is really pull out the key insights from their latest official update.
Yeah, give you a clear picture of where they are now, where they're heading, and, what it all means, this idea of connecting our brains directly to machines.
Okay, so let's get into the tech itself. They describe the device as a generalized input-output technology for the brain.
Right. Think of it like a universal port, but for your brain. A way to get information in or out.
Without damaging things, without side effects, which for a long time people thought was either impossible or maybe only done in very basic ways before.
Right, or already done, but not really, not at this scale. And this is where it gets really interesting, I think. The bandwidth problem.
Explain that. What's the bottleneck?
Well, think about how we communicate now. Talking, typing.
Oh.
It's slow,
Yeah.
really slow compared to how fast our brain works.
Okay.
We're talking maybe less than 1 bit per second, averaged over a day. Your brain has these complex thoughts, and then you have to squeeze them into words or key presses.
That's a huge compression.
Exactly. Neuralink wants to blow that wide open, increase the output massively, megabits, maybe even gigabits per second down the line.
Which leads to that phrase they use, consensual telepathy.
Yeah, it sounds like science fiction, but that's the goal, a much higher bandwidth connection.
So, okay, basic brain-computer interfaces, BCIs, they've been around for decades, right?
In the labs, yeah.
But this isn't just a small step up. You're saying Neuralink is aiming for orders of magnitude more bandwidth.
Orders of magnitude. It's not just making the cursor move a bit better, it's fundamentally changing the connection speed.
Because our brains compress thoughts into words, and that's lossy, as they put it. We lose information in translation.
Precisely. Think about trying to explain a complex feeling or idea. You never quite capture it all, do you?
No, never.
Neuralink hopes to create a more direct, maybe lossless pathway, communicating potentially thousands, maybe millions of times faster.
Wow. Okay, so where are they starting with this? What's the first product?
It's called telepathy, and the focus initially is, quite rightly, on reducing suffering.
Helping people who've lost control of their bodies due to accidents or diseases like ALS, spinal cord injuries.
Exactly that. People who can't communicate or interact with the world easily anymore.
And this isn't just theoretical. They're in clinical trials now.
That's right. In the U.S., and they've got approvals to start trials in Canada, the U.K., the UAE as well.
How many people are involved so far?
Last update mentioned 7 participants and their stories.
Yeah.
When they really show the impact.
Right, because the tech is amazing, but what does it actually do for someone?
Let's talk about Nolan, P1, the first participant. On day 1, literally day 1, he broke the world record for BCI cursor control.
Just like that.
Just like that.
Oh.
And he uses it constantly now.
Yep.
Learning languages, relearning math, writing, taking classes.
Things he couldn't do before.
He explicitly said, this is not something I would be able to do without the Neuralink. And he uses it for fun too, drawing, playing Mario Kart.
That's incredible. Restoring ability and, well, fun too.
Then you have Brad, P3. They call him the ALS cyborg. He's nonverbal, used to rely on an eye gaze system that kept him inside mostly.
Okay.
With Neuralink, he said he can go outside now, calls it a huge blessing. He turned on his TV by himself for the first time in 2.5 years.
Wow. Just turning on the TV, something so simple, but
It means everything, right?
yeah.
It's regaining control over your environment, your life.
Absolutely. And it's not just about basic functions either, is it? Some are using it for pretty complex tasks like gaming.
Yeah. Alex, P2, the guy from the intro, and RJ, P5, they're playing Call of Duty.
Seriously? How?
Controlling two joysticks at the same time, one with, like, thumb movement intent, the other with wrist movement intent. It's seriously impressive control.
That's coordination on another level.
And Mike G4, another participant, he highlighted being able to keep working, providing for his family because of the device.
So the independence aspect is huge. Is there data on how much they use it?
Yeah, they reported participants averaging around 50 hours a week of independent use.
50 hours. That's like a full-time job plus some.
And some peaked over 100 hours a week. It really shows how integrated it can become into their daily lives, giving them that greater independence.
Okay, so that's where they are now. What about looking ahead? What's the roadmap?
It's pretty ambitious.
Yeah.
So today it's about 1,000 electrodes, mainly in the motor cortex, the hand area, for cursor and gaming control.
Right.
Next quarter, they're planning implants in the speech cortex. The goal, directly decode attentive words from brain signals to speech.
Just think the word and have it spoken.
That seems to be the idea. Huge for nonverbal individuals.
Okay, that's after speech.
2026, they're aiming to triple the electrodes, 3,000 channels, and launch the first blind sight participant.
Blind sight. We'll come back to that. What about 2027?
Keep scaling. Up to 10,000 channels, maybe, and crucially, multiple implants in different brain areas, motor, speech, visual cortex, all potentially working together.
And beyond that, 2028 and onwards.
Aiming for over 25,000 channels per implant, accessing basically any part of the brain. This opens the door to looking at psychiatric conditions, pain, other kinds of dysregulation.
Wow.
And, very importantly, they plan to start demonstrating actual integration with AI.
Okay, that sounds like a major shift.
It is. The ultimate goal seems to be a whole brain interface.
Yeah.
Hundreds of thousands, maybe millions of channels, multiple implants working together.
Let's circle back to blind sight. You mentioned that starting around 2026. What is that?
It's essentially a visual prosthesis. The idea is to help blind people see again.
Even people blind from birth or who've lost their eyes.
That's the claim, even if the optic nerves are damaged. The concept involves glasses with a camera.
Oh, okay.
Camera records the scene, software processes it, and then sends patterns of stimulation to an implant in the visual cortex. Basically, trying to create visual perception directly in the brain.
Bypassing the eyes entirely.
Exactly.
Yeah.
And the potential long-term.
Yeah.
They talk about high resolution, maybe even seeing in different wavelengths.
Like Geordi LaForge in Star Trek, seeing infrared, radar.
That's the kind of superhuman capability they hint at down the road. Pretty wild.
Wild is right. So beyond vision, you mentioned neurological and psychiatric conditions, pain.
Yeah, by targeting deeper brain regions, like the limbic system, they hope to address conditions that are currently very difficult to treat.
And then there's robotics. You mentioned Optimus.
Right, the idea of potentially mentally remote controlling an Optimus robot, like inhabiting it, using its sensors, its limbs.
Or even just replacing a lost limb, like Luke Skywalker's hand.
That too. High-fidelity control over advanced prosthetics. But maybe even more profound is the idea of bridging damaged neurons.
For spinal cord injuries.
Yes, implants in the brain and the spinal cord, creating a bypass around the injury site. They believe this could allow people to walk again, regain full body function.
The ambition is just staggering. What kind of engineering makes this possible?
Well, a key thing is their vertical integration. They like to say they own the entire stack from neurons to pixels.
Meaning they build everything themselves.
Pretty much. Microfabrication, the implant design, the surgical robots, the software, the machine learning, it's all in-house.
Which must give them incredible control and speed.
Exactly. Look at the implant itself. It went from early prototypes that were, wired, had USB-C plugs sticking out,
Right, I remember seeing those.
to now this fully implantable, small wireless device that's visible once implanted. The engineering challenges there are immense.
Like what?
Making it hermetically sealed, perfectly airtight, with 1,000 tiny wires passing through, lasting for years inside the body. Wireless charging without generating heat. It's incredibly complex bioengineering.
And the surgery itself, it's done by robots.
Yes.
Yeah.
The R1 robot did the first 7 implants, took about 17 seconds to insert each tiny thread.
Okay.
But the next-gen R2 robot, it's 11 times faster, 1.5 seconds per thread.
Wow. That's a huge leap.
And it's designed to be compatible with over 99% of people's skull and brain anatomy, making it much more scalable. Plus, can insert those threads deeper, over 50 millimeters, reaching those subcortical areas we talked about.
That speed and precision seem vital if they want this to be widely available.
Absolutely. And tied to that is manufacturing. They've managed to drastically cut the cost and time for sterile components.
Like the needle cartridge example.
Yeah, from $350 in 24 hours down to just $15 in 30 minutes. You need that kind of efficiency to scale to thousands, eventually millions of implants a year.
Okay, so let's talk data. They're reading neuronal activations, not thoughts, right?
Correct. It's about interpreting the signals related to intended movement, or soon, maybe intended speech, not mind reading.
And how good are they at interpreting those signals now?
The progress is apparently huge. Cursor calibration used to take hours, lots of frustration. Now, they say it's about 15 minutes. Almost works right out of the box for the participants.
That makes a big difference for usability.
Totally. And the UI, the interface the participants use, is designed closely with them. Features for scrolling, parking the cursor, a software keyboard with dictation and swipe.
So it feels like a real collaboration.
It seems that way. And underpinning all the surgical planning is advanced medical imaging. They use high-end Siemens scanners, built a big database of brain anatomy from internal volunteers to ensure precise placement.
Okay, let's pull back again. What's the big picture here? Connecting our biological neural net to silicon neural nets.
That's a good way to put it. It's creating a fundamentally new way for information to flow between our brains and machines. It's like extending the brain's substrate.
Yeah. And this connects to that idea about AI risk. How does this help?
Well, the argument goes something like this. We're already kind of cyborgs, right?
Mm-hmm.
With our phones, computers. We have our biological brain, then this digital layer.
Okay, yeah.
But the connection, the input-output between our cortex and that digital layer is super slow, that bandwidth problem again.
Right.
Neuralink aims to fix that bottleneck. The idea is, if we can have a high bandwidth connection, humanity's collective intelligence, our collective will, can better keep pace with and hopefully steer the development of artificial intelligence.
So it's about merging, in a way, to stay relevant.
Or at least stay in the driver's seat.
It's a profound idea. And this concept of sensing more and more neurons, it could just completely change how we interact with everything.
Like the jump from dial-up internet to broadband.
Exactly. That's the analogy they use. Remember 56K modems?
Oh, I remember. Painfully.
Broadband didn't just make websites load faster. It enabled entirely new things, streaming video, cloud computing, social media as we know it.
Right. It changed the possibilities. Neuralink hopes this brain-computer bandwidth increase will do something similar for our interaction with information in reality. A much richer experience, potentially those superhuman capabilities.
So to wrap things up a bit, the key takeaway is that Neuralink is, well, it's working. Reliably, it seems, for these first participants.
Yeah, it's already changing lives, making a real impact for those 7 people. The next big challenge is scaling that to thousands.
And expanding beyond just movement control.
Right. Sophisticated robotics, speech decoding, restoring sight with blind sight, aiming for interaction at the speed of thought.
Which brings us to that final, really provocative thought for you, the listener. What does it actually mean to achieve superhuman capabilities when our brains become natively integrated with AI and tech?
Yeah, how does that shift our definition of being human, of experience, of consciousness itself when we start moving beyond purely biological limits?
Something definitely worth thinking about. We hope you enjoyed this deep dive into where Neuralink is heading.
Until next time, keep exploring.